Okay, check this out. We can use product of powers property and the power of a power property to find power of a product. Look for the patterns in the exponents below. So if I have t times w cubed, what does that mean? Well, that means multiply 3 factors of t times w together. So t times w times t times w times t times w, which if you regroup them means multiply 3 t's together and 3 w's together, which is really t cubed w cubed. So when you have a product to a power, you raise each factor of that product to that power. Let's see it again. 2 times y times z squared all cubed. That means multiply 3 factors of 2yz squared together. So 2yz squared times 2yz squared times 2yz squared. If I regroup it, you have 2 times 2 times 2 times y times y times y times z squared times z squared times z squared. Well, you would have 2 cubed times y cubed times z to the 6th, or the 2 cubed you can write as 8, so it's 8y cubed z to the 6th. But notice you raise each factor to a power of 3. So 2 cubed right there, y cubed right there. Now z squared cubed, that's power to a power, so you're going to multiply and get z to the 6th. Okay, those examples are going to demonstrate the property of a power of a product. So to find the power of a product, find the power of each factor and multiply. So basically you raise each factor in the parentheses to the power that is outside of the parentheses. Just be careful when you have negative numbers. Like in the example here, negative 2 to the 5th power, you would have to put that in parentheses, raise it to the 5th power. If it was negative 2xy cubed to the 4th power, you would have to write negative 2 to the 4th, x to the 4th, y cubed to the 4th. And guess what you'd get? 2 to the 4th, or negative 2 to the 4th, is negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. Then the rest would be x to the 4th and y to the 12th. Okay, so just be careful with negatives. Okay, remember, a negative times a negative is a positive. So when you're multiplying multiple negatives together or raising a negative number to a power, be careful. The answer is not always negative. All right, so here's an example. I want to express the area of a circle as a monomial. So this picture means that the radius is not actually a number. I don't know the actual radius, but I know the formula that gives me the radius is 2xy squared. Well, remember that the area of a circle is pi times r squared. So you do pi times the radius, in this case, 2xy squared, and square it. So if I plug that in for r, I'd get pi times 2xy squared squared. Well, I have a product to a power, so I raise each factor to the power. So it'd be 2 squared, x squared, y squared squared, or y to the 4th. Simplify that a little bit. 2 squared is 4, and you can put the pi at the end. Remember, when you're multiplying a whole bunch of factors together, you can multiply in any order. Typically, when you have multiple variables, you just put them in alphabetical order. That's why the x, y, and then pi goes last. Okay, so the area of the circle is 4x squared y to the 4th pi square units. All right, now I can't go any further because I don't know what x and y are. Okay, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. What you get? All right, I want to express the area of a square with a side length of 3xy squared. So the area of a square is its side length squared. So I have 3xy squared squared, which is going to be 3 squared x squared y to the 4th, or 9x squared y to the 4th. So that's 4a. 4b, express the area of a triangle. Well, the area of a triangle, you could look it up if you don't remember, is 1/2 the base times the height. So I have 1/2 the base which is 5 AB squared times the height, which is 4A. Now notice on this one, you didn't have any products to a power. You're just multiplying like bases. So group the coefficients. So 1/2 times 5 times 4. Group the variables. A times A times B squared. Okay. So think of 1/2 times 5 times 4. 5 times 4 is 20. Times half would give you 10. A times A is A squared. And B squared. That looks like a 7 up there, but it's really squared. So 10A squared B squared. There you go. Pretty cool, huh? All right. So we can combine and use all these properties to simplify expressions involving monomials. Okay, so to simplify a monomial expression, write an equivalent expression in which, okay, each variable base appears exactly once. In other words, if you have multiple a's and they're all multiplied together, you can simplify them. There are no powers of a power. So if you have like a squared to the third power, you got to simplify that. And if you have any fractions, you got to have those in simplest form. So here's an example. I want to look at this mess. Okay, I want to simplify 3xy to the fourth quantity squared times negative 2y quantity squared quantity cubed. All right, let's just go at it. So notice right here, I have a power to a power. So I can simplify that as 2 times 3 is 6. Now this almost looks like a power to a power, and it kind of is, but notice I have 3 times x times y to the fourth quantity squared, so that's a product to a power. Okay, but since this one is in parentheses, the negative 2y squared, I can just do 2 times 3 is 6. Okay, now I do the power of a product. The 2, this power of 2, you raise each factor to a power 2. So 3 squared, x squared, y to the fourth squared. This 6, I can do the product, the power of a product here, raise negative 2 to the 6th power and y to the 6th power. Okay, now I'm just simplifying a little bit here. The 3 squared is 9. The negative 2 to the 6th power is going to give you positive 64. And I'm simplifying also the power on a power here of the y to the fourth squared, which is y to the 8th. Okay, now I can group using the commutative property. I can group the coefficients and the variables accordingly. So 9 times 64 gives me 576. X squared is the only x, so that's good. Y to the 8th times y to the 6th. I'm adding exponents there and get y to the 14th. Alrighty. So each variable base appears exactly once. X here, y here. There are no powers of a power. I got rid of those up in my work here. And fractions are in simplest form. Well, I have no fractions, but I did multiply the 9 times 64. All right, here's one for you to try. Go ahead and pause the video. Okay, we're back. So first thing I want to do is get rid of the power to a power here. So I'm going to copy this whole thing and get 1/2 a squared b squared cubed times negative 4b quantity to the fourth. Okay, notice now these are products to powers. So I'm going to have 1/2 cubed a squared cubed b squared, or yeah, b squared cubed, negative 4 to the fourth, and b to the fourth. Okay, now I can simplify power of a power. Now, the 1/2 cubed means 1/2 times 1/2 times 1/2, which would be 1/8. A squared cubed is going to be a to the 6th. B cubed, I wrote that wrong. Let me erase that. That's going to be b squared cubed, which is b to the 6th. Negative 4 to the fourth. Negative 4 times 4 is 16. Times 4 is 64. Times 4 is 256. And it's going to be positive since I multiplied 4 negatives together. Okay, and then b to the fourth. Alrighty. So I can group coefficients. 1/2 times 256 times a to the 6th times b to the 6th times b to the 4th. 1/8 times 256 is 32. I only have one factor with a in it, so a to the 6th, and b to the 6th, b to the 4th can be combined as b to the 10th. Okay, they can get pretty tricky there, so be careful, but there you go. All right. All right, guys, that's it for this section. Please continue on to your assignment, and as always, reach out if you have any questions. Take care.